What's up, everybody? Today we're going to walk through the process of writing the code for USACO's 2019 January contest at the bronze level. Problem number 2, sleepy cow sorting. I'll be covering this in 3 languages, the Java language, the Python language, and the C++ language. This video assumes you're already familiar with the algorithm and understand the solution and just need help writing the code. If you have not yet read the problem, you probably should check the algorithm analysis video first. Okay, so just as a very brief recap for this problem, essentially what we're going to do is we've got our list of cows, and we're going to work our way from right to left, looking for the first cow that is not descending. That'll split the list into 2 groups, where the left side is going to be inserted into the right side. I have individual steps written out, starting from a hello world beginning. I also have the in files created. Since this involves a file reader, sleepy.in, you'll have to read from sleepy.in and write to sleepy.out. Note that the newer questions don't involve a file reader. For the newer questions, it would just be typed into the console. So this hopefully should cover all of the steps that you'll need in order to get started doing these bronze problems. Okay, so we're gonna start with Java. First thing we need to do is read data into a container. In order to do this, I need to be able to open a file. I happen to like reading files with a scanner. You can do it however you want. Import Java util scanner and import Java IO file. So we'll start by reading, making a file reader. We'll do scanner sc equals new scanner, new file, and then the name of the file will be sleepy.in. And then we'll do let's start by reading the first line, int I equals or int n rather equals, let's capitalize the n, sc.nextInt. And then for right now, we're just going to print out the n and make sure we got it. I should read that first file, which has a 4 as the first number, and then print a 4 out to the console. In the meantime, I'll start on the next part. So we need to read all the data into the container. I'm going to need an array list for that. Import Java util array list, most likely. Why isn't this running? There we go. Okay. First thing is file not found exception, potentially thrown by the file reader. Anytime you open a file, you need to throw the file found extension. The easiest way to do that is just to throw that up on your main line. Throws file not found exception, and I believe we have to import that. Import Java file not found. All right, we got the 4. So that shows that we've successfully opened the file and been able to read data for it. Okay, so what I'm going to do is I'm going to set up an array list. We'll call it numbers. It's going to store integer equals new array list. An array list is fine for this, since we can pre-design the size ahead of time, and also because we're going to be iterating in reverse through it. You can iterate in reverse, I think, through a linked list, but it's going to be much easier to do with an array list because we can instantly seek to any location. Integer. And we can specify the size here. It's not strictly necessary. It will speed it up a little bit. Let's see. And then we probably have to import list explicitly. Maybe not. Let's run that. Oops, got that integer in the wrong place. List numbers. Okay, let's try that again. And then we'll be setting the for loop for int I equals 0. First thing is to read the list of numbers. So for int I equals 0, well, I is less than n, I plus plus. Reading in the next int is going to be sc next int. And then we'll do numbers dot. We can use set, I believe, in this case, because we pre-designed the size. Otherwise, we'd have to use add. Set I. Let's just use add. add next int. That would then add it to the numbers, so that would give us our list of numbers. I'm gonna go ahead and test that, just to make sure that's working. My numbers. I like to test frequently when I go. I recommend doing this. A lot of times students will write an entire page of code and then they get to the testing part and it doesn't work and they're not really sure at what stage it broke down. Sometimes a problem is occurring farther down the file from something that was made, a mistake that was made further up. So it's kind of always good to test as you go. So you can see now I've got the 4 and the 1, 2, 4, 3. That shows that I've read that file correctly. Okay, so step 1, read the data into a container. I've opened up the file, I've read n, and I've also read the rest of the data into my numbers container, so that's good. Step 2, iterate from right to left, checking the previous index. Okie dokie. Int I equals numbers dot, I can just use n actually, n minus 1, while I is greater than 0. If it gets all the way down to 1 and confirms that the one in index 0 is still smaller, then our output finally should be 0. So we can just work our way right to left, stopping at that index, because we're always going to be checking against the -1 index. We'll do I minus minus. Okay, so then if numbers get I is strictly greater than, or is it, can it be increasing? Let me double check. I forget if there was repetition of numbers. I don't think there's any repetition of numbers. Yeah. So we have no repetition numbers, so it'll be strictly greater than, so we don't have to worry about if they're equal to. If numbers get I is less than numbers get I minus 1, or I guess if I write that right to left, if numbers at I minus 1, which is the number to the left, is greater than the numbers at the I location, then that means that's as far as I can go. So I'm going to store my answer variable. And answer equals, we'll start with 0 actually. And then the first time this occurs, we're going to update the answer. Answer equals I, and break out of the loop. So just to check if that's right, numbers, we're going to print out the answer. Out answer. In this case, the answer should be 3 if I've done that correctly. Let's see. Yep. Okay. And then I've got 3 as my final answer. I have to save the results to the file. In order to do that, I'm going to have to open a file writer of some sort. I like to use the print writer. Import Java IO print writer. Again, you're welcome to use whatever tool you want if you have a preference. We're going to do print writer. Oops. Writer. New print writer. New file. Sleepy.out. That'll create the print writer, and then we'll do out.write print line. I think print line. I like the print writer because you can use the same commands as just a system out print line. Out print line answer, and then closing the file. Out.close, and we really should close our scanner as well. That doesn't really matter in particular context. This is a good point to point out. A lot of times there are real-world practices or real-world standards or rules that we a lot of times don't necessarily follow when we're doing USACO problems. Global variables is a very common one. In the real world, we try not to use global variables, but for the sake of fast competitive programming, having global variables, even though it would be a security risk in the real world, is a way to not have to worry about passing variables around. So a lot of the solutions will use global variables instead of just having them passed through function calls. So can we not close the scanner? Let me try to run that again. Okay, there we go. And then sleepy.out. We'll open that, and that's got a 3 in it. Okay, I'm going to now copy all this code, and I'm going to put it in my favorite code editor. I'm going to try to save this, and then let's submit real quick and see how far along we are. This is for Java. Choose file. Let's see. I'm in the wrong folder. Code. Let me collapse this. I need to see all these. Okay, so I got my Java file open, and oops, take it open, and submit solution. See if we missed any edge cases. No, we're good. All right, So that's full credit on that problem using Java. So let's look at this code one more time and quickly review. I set my main up to throw a file not found exception. And again, you only need to do that on the ones that have file readers, which are from 2018 and before. We read the data into a container. I did this with a scanner and loaded it into an array list. We then iterate right to left. I did this using a for loop starting at n-1. Then as long as I is greater than 0, I worked my way to the left, getting the number and comparing it to the number immediately next to it. When I found the index where there was a number to its left that was not greater than it, I saved the index into a variable called answer. Right now I'm printing it to the console, which is again not strictly necessary. The important part is that I created the file writer here to sleepy.out and wrote the answer to the file. All right, moving on, we're going to go ahead and do Python. Step one, reading the data into the container. Now with Python, one thing that is an interesting thing about Python is in the Java language and the C++ language, it's very easy to read individual numbers, single integers out of a file sequentially. And a lot of times the way the code file is set up, where it gives you like an n value and then has a list of numbers, is very easy to, it's very conducive to writing a file reader that reads individual integers. With Python, we don't really do that. So there's a couple tools that you're going to use that are going to be a little bit different. Some of these you can just copy and paste or memorize, but I'll kind of briefly go into how they work. So first up is going to be reading a data into a container. So we're going to do f equals open sleepy.in. And then we're going to do, let's do n equals f dot read line. And then cows equals f dot read line. We'll print n and print cows. And just see if we're have a quick sanity check so far. We're on the right track. All right, read line. I think read line's lowercase l. Oops, this one as well. There we go. Okay. So one thing you'll notice when we read the line, we got a line break on the line. You always want to strip that. So it's going to be read line dot strip, also dot strip. Now regarding these cows, I've got this as a list, and it looks like a list of numbers. But if I were to print out the type of those cows, you'll see that this is a string. Whether you're using the file reading style or whether or not you're on the newer problems where it comes from the console, it still should probably be read in as a string. In order to fix this, what you can do is do cows equal int x for x in cows dot split. So what's going to happen here is cows dot split is going to turn this into a list of numbers. I'm going to print that real quick. Print cows dot split. Let's just go ahead and comment this out for now, or delete it. So I'll hit undo in a minute. Okay, so you can see that made a list, and I've got a list of numbers, 1, 2, 4, 3, but notice the quotes around them because they're still strings. So what this is going to do, this is using list comprehension. And what I'm saying is I want to create a list where I'm going to apply the function int to x for every x in cows.split, which is cows.split is this list of numbers right here. By doing this, then what I'm going to have is cows, which will be now a list of integers instead of a list of strings. So right now you can see it's showing as 1, 2, 4, 3 in quotes. After I do this, then I should have the n value as well as the number as a list. Likewise for n, this also has to be fixed. N equals int n. Since it's not a list, it's just a single number. That's a little easier to fix. Okay, so that gets us to n and cows. Next is to iterate right through left, checking the previous index. There's probably some advanced Python tools we can use for this, but we're just going to use the standard simple tools that you probably are familiar with. So similar to the last one, we have to do an iteration. I'm going to do for I in range n-1, comma. Now I have to put -1 as the stopping point, or no, I put 0 as a stopping point. But I want to point out that that means that there will be no 0. If I do print I, for example, just real quick to demonstrate that, it's going to go 3, 2, 1, and then that'll be it. Oops. Oh, I got to specify the direction is -1, going in reverse. Okay, so 3, 2, 1. So I'll have indexes 3, 2, and 1, which is exactly what I want for a length of 4, and then we won't go to index 0. So then here, the same rule is going to apply. I have this answer variable, answer equals 0. And then if the cows at I is, or at I-1, which is to the left, is greater than cows at I, that means they're out of order, in which case answer equals I, and we break. Keep putting semicolons, break. Okay, real quick, we're going to test that and see if that's the right answer. We should see a 3. All right, and we got to save to a file. We're going to do out equals open sleepy.out with writing, and then we're going to do out.write the answer, which I'm going to cast to a string. And then also, I believe we have to manually put a line break on the end of these in order for the grader to be happy. I'd have to double check that, but I'm pretty sure that was one of the rules. Finally, closing the file, out.close, and probably should close my original file as well. All right, if that works correctly, we should see sleepy.out, and it should have a number 3 in it, and it does. Fabulous. I'm going to throw this into my, oops, let's take that print world out, or hello world out. Throw this into my favorite code editor, Python paste. I'm going to save that, and then I'm going to go into here. We're going to resubmit as a Python file, Python 3.6, choose file, main.py, open, and submit solution. Give that a minute. All right, looks good too. All right, so just again, as a real quick recap, we're using the same steps, reading all the data into a container. In this case, I just used the list. Iterating right to left. So I did n-1 to 0, going in the -1 direction. Same comparison, saving the answer and breaking out if we find what we want, saving to a file, and then closing the file. Regarding the time, I want to point this out while we're here. So notice that on this in Python, my times were around, looks like around 180 milliseconds. The language is going to determine a lot of these times. I'm going to resubmit Java real quick just to kind of pull those numbers back up. So at about 180 seconds, 180 milliseconds for the Python solution. We'll look and see what the Java solution does comparatively. One thing to keep in mind, though, is they do scale your, see that came up with 329 seconds. Part of the reason Java is slow is it has to start up a virtual machine. Python gets going pretty quickly, but it individually reads lines of code a little slowly. So on the smaller programs, Python will be a little bit quicker than Java. On the larger programs with the larger test cases, Python will be a little bit slower than Java. They do scale the time requirements depending on the language, depending on the problem, though. So whereas you may have some number of seconds in Java, you may have a different number of seconds in Python. Rest assured, though, if your algorithm is correct, you should be more than passing with plenty of room to spare for all of the problems. The only time it really makes a difference is if you're not using the ideal algorithm. Occasionally, there will be one test case where it will pass in one language and not pass in the other, just because of timeout requirements. Generally speaking, though, C++ is going to be your fastest language, and it's going to be the most optimized for pretty much every problem. So, and again, you can solve all these problems in each of the languages because they do move the marker for where your timeout is, depending on the language. But if you have an imperfect solution, you may find that your imperfect solution is passing more test cases in one language than the other. And usually C++ is the one that gets away with a couple more points, which is why it's a very popular language. Also, it's pretty fast to write comparatively. So we're going to first include fstream, beginning the C++ portion. Reading data into the container. ifstream thin, sleepy.in. And then we're going to do int n, thin n, and just make sure that works, and end line, run. We're also going to need a vector. Okay, and there's our 4 for n. Vector int numbers for int I equals 0, I is less than n, I plus plus. Int, let's call it temp, in temp, and then numbers, push back. I probably should specify the size. The only reason to specify the size is depending on your data structure. When it creates these vectors or creates these array lists, I'm pretty sure vector works the same way. It budgets it as an array internally as a set size. A lot of times the starting size is just like 5 or 8 or 4 or something like that. And then once it fills up, when you try and add another number, it creates a new memory allocation and moves all the data over to the new memory allocation and then deletes the old memory allocation. What this means is that when your list gets full, you have a linear time copy from the current size to the new container. And if that only doubles the size, then you may have another linear time copy. Now, this should happen a logarithmic number of times, because if your starting container size is 8 and then it increases to 16, you're going to copy 8 numbers. If it then fills up to 16, it's going to double to 32, and you'll copy 16 numbers, which will have been a total of 8 plus 16. So you'll have copied 24 numbers if it doubles twice. Ultimately, what that means is that despite the fact you're doubling and copying, every time you do that, since the list size doubles, your overhead for copying the numbers is only going to be linear time. Because the total number of numbers you copy, you know, I'm going to write this down as a table here real quick. If I have 8 numbers to start with, and it doubles to 16, then I'll have 8 numbers to copy. If I then have 16 and double to 32, I'll have copied 8 numbers and 16 numbers, the sum of which is actually less than 32. And that rule is going to hold all the way up. 32 to 64 means that if I have 8 plus 16 plus 32, I'm going to, what is that, 56? Still less than 64. So essentially, as you're copying these numbers over, it does have a little bit of runtime complexity. That it doesn't change the runtime complexity, but it does make it run a little slower. So specifying the size to start with, again, it speeds up the code a little bit, but it's not strictly necessary to do. You can just trust the vector to push back and increase the size as it goes. And then it still should pass the test cases just fine. But if you really want to try and optimize, starting size is important. Okay, so pushback numbers. And then that should be done. Unlike Java, I don't have an easy way to just print out my vector, so I'm going to have to write a quick for loop for that. For int I equals I less than numbers dot size I plus plus cout numbers I. I'll just put a space and then cout. I'm just going to delete it in a minute anyway. That line. Okay, let's run that again. All right. Oh, right, because I'm using pushback. This should be numbers I equals temp. Otherwise, it's just going to put it at the end. So what had happened there is I created a size. This is why it's good to check. This is why we compile and do little tests as we go. Because if I got to the end and this wasn't working correctly, I might be confused why, and I might not even realize my vector doesn't have what I thought it did. If you specify the size, that's interesting. So with Java, I hadn't really thought about this. With Java, I specify the size. But if I were to do it add, it doesn't add it to the back. It just adds it to. So the initial size is still going to be 0, and it'll add it where appropriate. If I wanted to use set, I could use, I believe, set I to a certain value, and then that would work very similar to how the C++ works. In C++, I specify n, and then if I push back, it actually goes back behind that last element. So I still have to assign it using the index. All right, so that's good. Let's rerun that. I think that's fixed now. Iterating right through left for int I equals n minus 1, while I is greater than 0, I minus minus. Also, incidentally, you really should use size t for this. I'm being lazy and I'm not doing it. These are going to be unsigned in this case because I'm working in positive indexes and because this is somewhat based on the size of the numbers. Using a size t probably is strictly more appropriate, but I'm just going to use integers anyway. Okay, I equals 1, I is greater than 0. But if you did use, the reason I'm pointing that out is because if I was, instead of using n, if I was doing like numbers dot size or something like that, then this would want to be a size t instead of just an integer. We'll leave it as an integer though, because n's an integer. All right, if numbers at I minus 1 is greater than numbers at I, then we're going to save the answer. And answer starts as 0. Answer equals I, finally breaking out of the loop. And then save the result to the file. We're going to do, I got to create an output file, ofstream out equal, actually not equal, so we'll do this, sleepy.out. Then we'll do out, answer, end line, and then out.close, and we'll go ahead and close fin as well, close, 0. Just to be polite. Okay, we'll run that. And then should see sleepy.out with a 3 in it, hopefully. Ooh, I broke something. What did we do wrong here? Doesn't like my fout. Oh, writing backwards. Okay, sleepy.out. And there we are with the 3. I'm going to grab the code and put it in my favorite code editor. CPP file, save. Go to USACO again and choose C++, go 17, choose file, main CPP, and we're going to submit. All right, that looks good too. All right, so I mentioned runtime complexity in the middle of the video, but if you skipped ahead, you might not have seen it. But I wanted to point this out. So notice my answers here now. I've got 2 milliseconds for the fast cases. The longest one was 14 milliseconds. In Java, I was around 300. And in the Python solution, I was around 180. So C++ is strictly a faster language. It doesn't have to worry about a virtual machine. It doesn't have to read characters out of the file. It actually is compiling into executable code, and then the executable code can run directly. So a lot of people do want to switch to C++ for this reason. Again, it's not strictly necessary. I've had students passing at all levels with any language, but you know, if you're undecided about the language, you may also find that when they publish the solutions, a lot of times the solutions are published in C++ rather than in Java or Python. So you know, again, use any language you want, but if you're ambivalent, or maybe if watching this inspired you to realize that actually the difference between the languages is not tremendously different compared to what you're doing in Java. It's the same steps. It's just the way you write it's a little bit different, or compared to Python. All right, that concludes this video. Hopefully you understand the code for that. Now we'll be posting the code. I'll have to figure out how to do that, but I'll be posting the code files so you can review those as well. And other than that, I'll talk to you on the next video.